Hello guys, welcome. Our today's topic is decision tree. What is decision tree? Decision tree are a type of supervised machine learning algorithm where the data is continuously split according to certain parameters. This tree can be explained by two entities, namely decision nodes and leaves. The leaves are the decisions or the final outcomes, and the decision nodes are where the data is split. A decision tree would look like this, where the topmost node is called a root node. The intermediate node are called split or decision node. Each branch of a node represents outcome of a test, while each node denotes the test attribute, whereas the leaf node holds the final output or outcome. Let's look at the algorithm of decision tree. Start with a training dataset, say D. It should have an attribute, that is inputs, and classification, that is outputs. The next step is to determine the best attribute in the dataset. Don't worry, we'll cover this in the coming part. The third step is to split the dataset D into subset that contains the possible values of the best attributes. The fourth step is to make the decision tree node that contains the best attribute. Fifth is recursively generate a new decision tree node by using the subset of data created from step 3 until a stage is reached where you cannot classify the data further. Represent the class as a leaf node. Now, let's see why to select the best attribute and why it is so important. Now, the most important part of a decision tree is deciding the best attribute. The selection of best attributes heavily affect the decision tree's accuracy. What is the best attribute? Decision tree splits the nodes or data on all variables and then selects the best attribute or a split which results in most homogeneous subnodes. So in short, the best attribute means the attribute which has the most homogeneous subnodes, that is most information gain. If you look at the below diagram, the left split has a less information gain as the data is split on two classes which has almost equal positive and negative examples, while the split on the right has more positive examples in one class and more negative examples in the other class. In order to calculate the best attribute, we use Gini index. Let us consider the simple dataset to see how to choose the best predictor or best attribute by Gini impurity. So this is our dataset. Here there are 4 independent variables to determine the dependent variable. The independent variables are outlook, temperature, humidity, and wind, while the dependent variable is whether to play football or not. Let us first calculate the Gini index of the output variable. The formula for Gini index is this, where C is the total number of classes and P is the probability of each class. As there are two classes yes and no in our output variable, the Gini index of output variable will be 1 minus sum of square of probability of yes and probability of no. So let's do the calculation. So the Gini for the output variable comes out to be 0.4591. We have calculated the Gini of our output columns, that is Gini plate is equal to 0.459. To choose the best predictor, we now calculate the Gini gain of outlook, temperature, humidity, and wind separately. First, consider the case of outlook. If you just consider the output and the plate column, you will get the below findings. So, the output, the outlook column has three categories: sunny, overcast, and rainy. Consider the sunny category. There are 5 instances where the outlook is sunny, and out of 5 instances, children have opted playing football on 3 occurrences, whereas children have opted not playing football on 2 occurrences. If we consider that the outlook is overcast, there are 4 occurrences where the children have opted for playing football, and there is no occurrence where children have not played football. When the output is rainy, there are total 5 occurrences, out of which 2 occurrences are where children have played football, while there are 3 occurrences where children have preferred not to play football. Using this data, let's apply our Gini formula. So the Gini of outlook is equal to weighted Gini of sunny category plus weighted Gini of overcast category plus weighted Gini of rain category. Now let's substitute our values in the formula. So the Gini of outlook column is 0.342. So the Gini gain of outlook column is Gini of our output column, that is played, minus Gini of our outlook column, that is 0.459 minus 0.342, that is 0.117. In the same way, we can calculate the Gini gain of temperature, humidity, and windy. I have done this calculation for you. As the Gini of outlook is higher than others, our best predictor here is outlook column, and the root node will be formed by outlook column. Now that we have seen what is a decision tree and how to calculate the best predictor, we'll move on and see what are the advantages and disadvantages of decision tree. Advantages of decision tree. Decision tree are super interpretable. Decision trees require little data processing. Decision tree are suitable for low latency applications. Now let's look at the disadvantages of decision tree. The major and the most disadvantage of decision tree is more likely to overfit the noisy data. The probability of overfitting or noise increases as the tree gets deeper. The solution for this disadvantage or problem is pruning our decision tree. We'll discuss about pruning more on our upcoming videos. Thanks for today. That's it.